The ciliary body, that was just an FYI. Choroid is the blood vessels, rods and cones, right? So rods do not discriminate light colors. No colors, highly sensitive to light. So this is what you would see with night vision and peripheral vision, very sensitive. And then cones are fovea centralis, right? The center of the macula. It could be called macula lutea or even macula densa. If you Google this online, macula densa is going to refer you to the kidney, which there is a dead spot in the kidney as well. The word itself just means dense spot. So again, like crispy apples, very pricey. Oh, go. Woohoo! Go and memorize this. What do I have here? We're not going to go through that. Don't worry about this. This is upper division, but we have, again, the optic disc. What is the optic disc? Soon we're going to see something called a blind spot. And what is a blind spot? Well, I have photoreceptors throughout every part of this. You see all these guys? These represent the photoreceptors, right? This is the neural part of it, the photoreceptors. But the optic disc, you notice there's no photoreceptors. So it's also known as the blind spot. It's the area that has the passage of the optic nerve as well as some of the blood vessels like these arteries and these veins that pass through. And because there's no photoreceptors, there's no transmission of image. So here we go. This is the dense spot. You see the macula? It's a dense spot or it's a yellow spot, and it has the fovea centralis in it. This guy is the optic disc. It's your blind spot because it has no photoreceptors there. Don't worry about that. Optic disc, again, was blind spot, something for you guys to memorize. And this is something that if you guys did in a lab, if you didn't do it in the lab yet, don't worry. You can practice this right now. So what I'd like you to do is walk towards the light. No, walk towards the screen and see at what point you're going to have one of these images disappear. So you stare at one or the other. Let's say you stare at this one. Please don't do this at home. I was just joking. But if you do want to do it, you can pause it and stand back and walk closer to see if the plus sign disappears as you're staring at this one. It's pretty fun to do. Chambers of the eye. We already went over this. Light crispy apples, very pricey. Oh, go. Woohoo! And I said aqueous humor, intraocular pressure, and this is associated with what? What do we have here that's not on this? We said it was called glaucoma. Very good, glaucoma. So again, light crispy apples, very pricey. Oh, go. Vitreous body is the jelly-like mass in the back of the eye. Light crispy apples, lens, right? Lens can adjust, and if I have clouding of the lens, it's called a cataract. We already did this, so this is great practice points. I'm not going to test too heavy on this. This is more of like physics principles. You just want to understand a couple of things. So I'm going to ask, how do you correct vision problems if you're nearsighted versus farsighted? Let's not go over the mechanics. If you want to do mechanics, you can always take the physics classes that test you on it and give you equations on images and if they're upright, if they're virtual, if they're real. We're going to keep it simple. So if I have somebody that is farsighted, we just say hyper, far, vexed. If I have somebody that is nearsighted, we say my close cave. Sometimes I forget this, but it's just a easier way for you guys to learn the material. We'll talk about it when we cover it shortly. So hyper, far, vexed, I already gave you a definition. I said hyperopia is also known as farsighted, and somebody that has myopia is nearsighted. And then how do I treat? Well, if we'll come across the image again. Let's say that your eyeball is squished and not in the right way. And I have an image that's out here, and I need to get the image onto the fovea centralis. If the image falls either before the retina or after the retina, then is your image going to be clear or blurred? Well, it's going to be blurry. So what do? We have to focus the image onto the retina in order for the vision to become clear. And it's not that it has to be on the retina, it's that it has to be in the fovea centralis in order for your image to be clear on the retina. So how do I do that? I can use a convex lens, and we'll see it when we come across it inside of the PowerPoint. Or, in this case, I can use a concave lens. So a convex lens or a concave lens. Here we go. This is the focal point, so let's get through astigmatism. Condition where light passing through the cornea and lens is not refracted properly. Visual image is distorted. I don't think they have one of the practices. When you're in the lab, they'll give you something that looks like this, and then there's lines coming across. And you might have seen this in the doctor's office, and I think this says, like, it'll just go over numbers. So 12 o'clock, 1, 2, 3, 4, 5, 6 o'clock. And it just goes through numbers like 1 through 12 or whatever numbers they have. And so the question that they ask you is, okay, can you tell me which lines, so you tell me the numbers, which lines are darker than the other? And so let's say that you tell them it's numbers 3 and numbers 5. And then you ask them, oh, are those numbers actually dark? Are those lines dark? And they say, no, it's that your eye is squished. And so if your eye is pulled in any direction, it's misshapen, it can cause this thing called stigmatism, right? Condition where light passes through the cornea is not refracted properly, so astigmatism. What was accommodation again? It's the ability of the lens to change shape, and then you have to have convergence of the eyes to watch the image coming closer at you. So here we go, close vision, far vision. So I want to make sure that I get it on the fovea centralis, right? Same thing, I want to make sure that I get it on the fovea. Want to make sure I get it on the fovea. So visual acuity, right, is due to the cones, and normal rating for visual acuity test, which is done by the Snellen chart, is 20/20. Light, we're not going to cover that. Don't worry about the upside down image and that. But we do need to know myopia, nearsightedness, and how do I correct it? So what was my mnemonic? So I said myopia was for near vision or close. And how do I correct it? I correct it with a concave lens. So let's look at this. I need to correct it with a concave diverging lens. So if your eyeball is misshapen, let's say it's squished. It's squished down this way. Squished down this way. Let's go back. Squished down this way. Then it pushes the retina farther back. You need to have a lens that opens up and widens to allow for the light to be shown a little bit higher than what it would be here, to push the image backward a little bit. And same thing for the hyperopia, which is farsighted. So we said memorize hyperfarvexed, which was hyperopia or farsightedness, is corrected with convex lenses that help to bring or angle in the image of the light so that when it falls on the lens, it focuses in a little bit forward than what it should be, or what it typically would be on a person that has I'm not going to say normal shape, but somebody that has the ability to see both far and near. Surgical correction, we said anything with the lens you can always replace, or in this case LASIK, right? Laser assisted is when they cut into the cornea to allow changes in how the image lands on the retina. So rods and cones, we went over already. Let's get through this. This guy is fun. Vitamin A, retinol, which is associated with the color, right? Rhodopsin. That one is, like we said, taken from vitamin A. I think this is it. So red, green, and blue cones. Color blindness, typically gender-based and passed on genetically. So bleaching of cones. What does that mean? Let us say that you are staring at a piece of paper and the piece of paper is blue or green. And after 30 seconds of staring at it, I remove the paper and I tell you to look at a piece of white board. As you stare at the white board, the color that's remaining that was not bleached out will reflect. Why is it reflecting off of a whiteboard? Well, the whiteboard represents all the colors of the rainbow, right? So if I stare at blue or green, let's say I stare at both blue and green, and I bleach out the colors blue and green, what color is left over again? Well, it's going to be red. So if I have red cones, because let's say I bleach out like blue, red and green make kind of an orangish purple color. So it depends on how much you bleached out of the other two colors or of the blue. So it is bleaching of cones will result in the different color that's left over. Does anybody see what number this is? Is there anybody that doesn't see what number this is? It is the number 26. I'm just joking. What number was it? It was number 12. So this is an example of color vision or color blindness. Photoreception. Yeah, let's get through this. I'm not going to test you guys on that. Don't worry too much. Dark light adaptation. Nope. On-off sensors. Nope. Optic radiation. We said optic radiation was also known as lateral geniculate body. Nope, it wasn't known as this, but it links lateral geniculate body with visual cortex, so this was also known as geniculocalcarine tract. Test questions. Depth perception. So depth perception requires both the right and left eyes in order to see whether or not something is in front of the other, because you need to see around it on both sides, right? So if you don't have the ability to see depth, then you're not going to be a flight attendant, not a flight attendant. You're not going to be a pilot. Okay, and there we go, questions. So what is the pathway for light entry into the visual system? Light crispy apples, very pricey. Oh, you guys can go back on that. What makes up fibrous tunic? We said that was sclerocornea. Vascular tunic, choroid, I think it was ciliary bodies, and the iris. Sensory or nervous tunic was basically the retina, the photoreceptors that were found on there. What is our fovea centralis? You guys already know that. I'm not going to even repeat. So these three are pretty much related to one another. This just means a dense spot. This means a yellow spot. And this is the center with the C. Optic disc is also known as blind spot, right? So photoreceptors, rods, and cones, which ones are associated with night vision, and peripheral vision, which ones are associated with color, clarity, acuity. What are cataracts? You guys can go through that. What is glaucoma? What is meiosis versus mydriasis, right? This was dealing with pupillary constriction and pupillary dilation. I'm not going to tell you what that is, but you guys already know what it is. Myopia and hyperopia. This was farsighted, nearsighted, and that what lenses were associated with correcting these visual disturbances. And finally, accommodation was a combination of what and what.